Let me increase the sizes. Right, I have placed here the Cartesian planes below. My point is, let me, yeah, I'm removing this and placing this here. So let's try to graph the function. Okay, the graph of the function is not something that you could just decide on the values. As mentioned earlier, for you to be able to see the entire parabola, you need to understand or give emphasis to the vertex. As mentioned, the vertex is the turning point. If you are not going to consider the vertex, you might just have this parabola, or worse, this part of the parabola. It's a line. You are not anymore looking at the curve. So in order for you to understand how the graph should look like, we need to give proper meaning to the vertex. The vertex should be placed here in the middle. I am going to use red. We're going to pick here vertex, place here, and decide the next values here in order for us to get, or the coordinates. Okay, we're going to decide on that. In order for us to determine the vertex, we have the formula. Again, the vertex should be a point. A vertex is a point on the Cartesian plane xy. But we are also could have a representative x and then f of x. Meaning, whatever the value you are going to substitute here, okay, whatever the value for x, you will get a representative value for f of x, and that's your y. So let's start with the vertex. The vertex can be computed with x equal to negative b over 2a. Okay? Negative b over 2a. So we are just going to use the coefficients, and after that, we are going to get the value of x, and that value of x will be substituted in the given to get our vertex. Okay, so let's start with the vertex. This is our vertex, okay? Okay. So let's try. Our b is 0, so negative 0 over 2 times 3, which is the value of your a. Well, regardless or no matter what the value of your denominator is, since your numerator is 0, your x for your vertex, x coordinate of your vertex is 0. So you could just simply place it here already if you would like to. That's already the value of x for your vertex. Okay? Now, to solve for its pair, we could substitute that on the given function, 3x squared. So when we use x equals 0, we are getting f of 0. Don't worry about this. It's just simply saying that we are changing the value of x to 0. So we have here 3 and then 0 squared. And of course, that's 3 times 0, which is 0 squared. And you will get a result of 0. So the partner of the x coordinate, which is 0, for the vertex is also 0 for f of x or y. So 0, 0. Or in short, our vertex is at 0, 0. Okay, as mentioned, that vertex is placed in the middle because our graph should be a parabola. And if that vertex is not placed on the middle, we cannot see the curve for both sides. So let us have this here. Now that we have decided, already identified x being 0, we are going to locate two integers below and after it, above it. Now, even if your value is not a whole number or an integer, let's say 1/2 or whatever it is, pick integers above and below it. So the values here are 1 and 2, and -1 and negative 2. Okay? And this would be the values that you are going to slowly substitute in our given to get the intended pairs. So if we're going to try 1, f of 1, to our given, which is 3x squared, it's just simply saying 3 times 1 squared, right? Which will give you 3 times 1, and we will give a value of 3. In short, the other point that we could use on our graph is the pair of 1, the value of x you used, and the 3, the value of f of x or y after getting the value or substituting the value of 1. So you're going to place it here, 1 and then 3. For f of 2, same thing. Okay. So 3 times 2 squared. Applying the correct PEMDAS, you start here with exponentiation. That's 3 times 4, which is actually 12, right? So the next pair of point is 2 and then 12. So you place here 12. For the negative value, this is actually where some of us will see it complicated, but you just need to use proper implementation of the negative signs under parentheses or says, parentheses, if there are more than one, and use the proper MDAS. So negative 1 squared, that's 1. So you will have 3 times 1, which will give you another value of 3. So your point is at negative 1 and 3. And finally, for the last integer, which is negative 2, you would see here a value which is a result of sorry, result of 3 and negative 2 that is subjected to an exponent of 2. So PEMDAS, negative 2 squared is 4. So 3 times 4, you will still get 12. By the way, for the information of everyone, you have a, a way of checking whether your substitutions are correct or not. Simply look at your table of values, and when you complete it using your uh, computed values, you would see this pattern that the next step after vertex, you will have the same values. And another step after the vertex, you will have another same values. This is made possible by using the same steps of integers above and below. If ever your answer here for this specific point is negative 3, that would mean they are not the same, and hence you need to look into your substitution if you applied it properly or not. Again, that's your way of checking. Let's graph this first, okay? So that we could jump to number 2 after graphing this. So we are going to take all of these values, copy this, and you have your Cartesian plane here at the bottom, okay? It's a little bit bigger. Let me make it smaller. I like that. I also included the predictions earlier so that we could really say if it's really true or not. So if we are going to place it here, let me add this line. Oh, sorry, line. This line here that represents our y-axis, and let me add it here. This line that represents our x-axis for our Cartesian plane. The largest, as of the table of value is concerned, the largest value of y is 12, but it's a little bit shorter here. So let me do it like this. Let us try to use, uh, yeah, let's make this per 2, 2, 4, 6, 8, 10, and then 12. Sorry, that's 10 and 12. Again, Let's use the grids per 2 because the largest is 12. So the first point that we are going to use here is the vertex at 0, 0. So the vertex is here. The vertex is here. Then you plot 1 and then 3. Let me use green. Again, we're using 2 values per grid so that it would occupy all. So this is where 1 is, not here. And then 1 and 3. Okay, again, 1 and 3. So if this is 2, 3 is here in the middle, and 1 here in the middle, your 1 and 3 is somewhere here. Okay. Next, 2, 12. So 2, this grid, 2, 4, 6, 8, 10, 12. If you're going to use multiples per grid instead of 1, 2, 3, 4, make sure that your multiples will be true for both axes. Not just for x-axis or y-axis, but for both axes. Okay? For negative 1 and 3, negative 1 is here, 3 is in the middle, so it will look like that. And then you will have here 2, negative 2 rather, and 12, negative 2, 2, 4, 6, 8, 10, 12. Okay? And the graph should look like a curve that will connect all of these 5 points, representative points rather. But we could still have more. If you're going to choose another point here, 3, negative 3, so on and so forth, you could pick more. But 5 is already okay for a parabola. So if I'm going to connect this, and pardon if I am not going to make this a little bit perfect. Again, let me just simply draw. Okay, pardon for the graph, but it should look like this and that. It should pass through these points. Okay, my hand is a little bit shaky. So the important thing here is you also need to include arrowheads. Okay, include arrowheads like that here and here as well. So it's a little bit curvy, actually, or a little bit awkward, but it's like that. Okay? So just for this representation, okay, the shape is a narrower parabola. It's a narrower than the normal one. If you are wondering what the normal one will look like, you could also look into that with x squared only, not the 3x squared. It opens upward, looking at the figure, and look, the location of the vertex is on the x-axis. It's on the x-axis, like here, right? On the x-axis. Okay? So it really captures all the three. Okay? It captures all the three given, what they call this one, predictions or analysis of our graph. Okay? So we have this for our graph. To graph number 2, we need to identify the same vertex, and the vertex will be given by a pair of f of x, I mean x and f of x coordinates. And we all know that x can be computed by negative b over 2a. Okay? So it's negative b over 2a, and b here is still 0. So negative 0 over 2 times a, which is negative 2. No matter what the value of the denominator is, your x is 0. Okay? And we are going to use that to get its pair using the same function, and we just simply change the values of x to 0. So you will have here negative 2 and then 0 squared. The entirety of this is 0. In short, same as earlier, our vertex is located at 0, 0. These points, or this point, with its coordinates shall be placed here in the middle. So you have 0 and then 0 here. Right. Then we pick values for both sides of the equation. You have negative 1. Sorry. We have 1 and 2. And you also have negative 1 and negative 2 here. Two vertices above and below the x coordinate of the vertex. And we are going to use these values, substitute just like what happened earlier to our function. So f of 1 is equal to negative 2 times 1 squared. Using the correct use of PEMDAS, that's negative 2 times 1, which will give you negative 2. The first point, additional point for our parabolic graph, is at 1 and negative 2. As for f of 2, the result will be the simplified form of negative 2 times 2 squared, which is negative 2 times 2 squared, which is 4. This will give you a result of negative 8. I already told you earlier that there is a specific pattern as for the values of f of x or y so that you could see the correct form of parabola. So let's see if it's the same case here when the second point rather is positive 2 and negative 8. We place it here. We start with negative 2 and this is negative 8 here. So it should be given that for this expression, for this point, this is also negative 2 and this is also negative 8. Again, let's continue. F of negative 1 is equal to negative 2 times the square of negative 1. We need to simplify first the exponentiation. So you have negative 2 times the square of negative 1, which is positive 1. It will give us negative 2. So the first pair, or I mean the first two pairs after the vertex will have the same f of x or y value. This is negative 1 and negative 2. And finally, you have f of negative 2. Substitute here. So negative 2 squared. You will get negative 2 times 4. And that's negative 8. So we have here negative 8. So just like this, we have correct representations of our f of x. So let us copy this and place it below. In order for us to graph our second function. But let's make this a little bit smaller, just like that. So we have predicted that the graph should be narrow, facing downward, and the vertex is on the x-axis. So since we are already predicting this at downward, let me draw our x-axis a little bit higher, probably here, so that we could see the entire parabola. And another one here for the y-axis. So we plot the points starting with the vertex at 0, 0. So the vertex is really on the x-axis. Next, you have 1, negative 2 here. And negative 1, negative 2 here. So since the points are already below, we are expecting that it's already opening downward. And to complete, you have 2, 1 through 3, 4, Again, 1, 2, 3, 4, 5, 6, 7, 8. The next point is here. And negative 2, negative 8. 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5, 6, 7, 8. Let me do it again. 2, 3, 4, 5, 6, 7, 8. That's correct. Just like that. And when you connect these, assuming again that my graph is good, so the parabola should change its direction here in this vertex and it will go down. Pardon if it looks a little bit V, but it's not V. It should be curvy down here. And this is your graph. So it opens downward and it's a little bit narrow and it's on the x-axis. Let's proceed to number 3, right? So the predictions are it's a wider parabola, it opens upward, and the vertex is located above the x-axis. Let's find out if it's really true by first solving the value of or the point for the vertex. Again, a combination of the x coordinate and f of x using the value of x. We start with the x, which is negative b over 2a. And since again b is not around, we expect this to become negative 0. And even if a is fractional, like 1/2, since the numerator is 0, it's just a 0. Using the given function, f of x is equal to 1/2 x squared plus 5. When we substitute 0 here, you will have 1/2. The square of 0 is 0. Okay, that's 0. Pardon. Like that. And you will have here 5. This entire expression will become 0, and hence you will be left with the value of c, which is 5. So this is not different from the first two functions where our vertices are found on the same point at the origin 0, 0. Here, the vertex is now at 0 and then 5. So we place this here in the middle, 0 and 5. And look for additional points or values of x. So we will have 1, 2, negative 1, and negative 2 here. And let's substitute to our given, which is f of x. Or we could just simply... So let's start with 1. F of 1 is we will have 1/2 times 1 squared plus 5. We'll have 1/2 plus 5, which is actually 5 and 1/2 or 11 halves. Next, for f of 2, you'll have 1/2 times 2 squared plus 5. Don't worry about fractional values. You just need to identify the correct placement of the points later. By the way, this is 11 halves or 5 and 1/2. As for this, you have 1/2 times 2 squared, which is 4 plus 5. So this is 2 plus 5, which gives you 7. So this is 7 here. The points are 1, 11 halves or 5 and 1/2. And you will have here 2 and 7. So just by the analysis earlier, this should also be 11 halves and this should also be 7. Let's still continue. F of negative 1 is equal to 1/2 times negative 1 squared plus 5. The square of negative 1 is just 1. So you are left with 1/2 plus 5, which is, again, 5 and 1 half, or 11 halves. That's why you will have negative 1 and then 11 halves. And you will have f of negative 2, which is 1 half times the square, again, the square of negative 2 plus 5. The square of negative 2 is just 4. So 1 half of 4 plus 5, which again results to 2 plus 5, and ultimately it's 7. So the points, or the point here, is negative 2 and then 7. So again, they have the same results here. So let's try to again copy this together with the prediction as we graph this here on the Cartesian plane below. And let's check if it's really wide, opening upward, and the vertex is above the x-axis. If we start with the axis. So let me have it here. I'm sorry. Let's have here the x-axis, and a little bit probably y-axis could be placed here because we are predicting it to be opening upward. So the 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. Let's make the x-axis a little bit lower. Right now. Okay. For the vertex, it's 0, 5. So 0, 1, 2, 3, 4, 5. It's again 1, 2, 3, 4, 5. It's here. So as you can see, the vertex is already above the x-axis as predicted. Then 1 and 11 halves, or 5 and 1 half. So it's here. And here for negative 1. And you will have 2 and 7. It's already 5, 6, and you have here 7. This is also 7 here. So looking at the points, it really opens upward. And if you're going to consider the shape of the graph, it's a little bit wider than the normal. So it covers the other two predictions earlier. This is the graph for number 3. And to the last function, we have this. The vertex shall be solved first, x and f of x. So we start with the formula for the x, which is negative b over 2a. Again, there's no b coefficient here. So you could just simply say it's already 0. Or if you would like to, you can write here 2 times negative 1, which will give you 0. We use that value to solve for the pair f of x. So let's already substitute f of 0 to the given, which is negative x squared, in this case 0 squared, minus 3. That's actually 0 squared is 0, and the negative of it, it's still 0, minus 3. You will have the value of negative 3. So the vertex is at 0 and negative 3. Same as the previous number, it's no longer at the origin. And since we have predicted it's below the x-axis, so it will not touch that point as well. So it's 0 and negative 3. Same values, 1, 2, negative 1, negative 2. And we slowly substitute this. Let's start with f of 1 to the given, negative of 1 squared minus 3. Again, please use the correct operations, especially if we have negative integers. That's negative 1 minus 3, which is negative 4. The first point is at 1 and negative 4. So negative 4 here. For f of 2, So it should be negative of 2 squared minus 3. You will have negative, and the square of 2 is 4, minus 3. So you will have negative 7. So the second point is at 2 and negative 7. So we have here negative 7. And again, as expected, it should be negative 4 and negative 7 here. But let's check it anyway. So f of negative 1 given is negative of negative 1 squared minus 3. Do not use the double negative property here since we will be using first the PEMDAS. So you will have the negative, the square of negative 1 is just 1 minus 3, and hence again you will have negative 4. Also true for f of negative 2. You cannot use the double negative property. You need to apply the power law or the exponentiation first. So you will have the negative of the square of negative 2, which is 4, minus 3, which gives you negative 7. So the additional points are negative 1, negative 4, and negative 2, negative 7. Same as the predicted pattern here. So this is now the complete table that will give you a more concrete form of the parabolic graph. Let's hope we could really see the graph here when we use these values. So the predictions are already given here. And since it's below the x-axis, let me just place the x-axis here since for the prediction. And here would be this, the y-axis. The vertex is at 0 and 3. 0, rather, negative 3. And then it follows 1 and negative 4. So 1 and then negative 4. And then negative 1 on the other side, also negative 4. And you will have here 2 and negative 7. 4, 5, 6, 7. Again, 1, 2, 3, 4, 5, 6, 7. And here 7 as well. To those who are wondering, this is actually the normal form of the parabolic graph. Normal in a sense that the coefficient is just 1. So it's the shape is a little bit normal than what it used to be. Unlike the first three examples, narrow, narrow, and wide, you have here normal. So it opens downward. The location of the vertex is below the x-axis, and it's normal. So you have this graph. So these are your 4 graphs here at the bottom for your 4 functions. This is for your first function, second function, third, and fourth. If you're wondering if these are really correct and try to verify if the points or the vertices are already correct, you could use Desmos for this. Desmos is an online graphing calculator like this, and where you could input your values here, or your functions rather. So let's start placing our function here. We have our keyboard here and all letters. So let's start with the first function, which is f of x equals 3x squared. This is our first function here. So my graph is not really aesthetically correct, but it should be similar to like this. If it's not, then our graph may be incorrect. So f of x equals 3, and then you have here your x and then squared. This is the graph. The vertex is at 0, 0. As you can see, the vertex is at 0, 0. The other points, you have 1 and 3, negative 1 and 3. Earlier, we used here by 2s for each grid, since it may not cover, or our Cartesian plane will not cover all of this. But it should have 1 and 3. So here, 1 is somewhere, if I'm going to increase this, 1 here, and 3. As you can see, there is that point. The other side, you also have this, negative 1 and 3. And you have 2 for 12, negative 2 and 12. So 2 is here, 2, and you have here 12. Right there, 2 and 12. The other side will have 2, -2, and then 12. So this is our graph using Desmos. And this is our graph earlier, our rough sketch of the graph, though it's not aesthetically beautiful, but it's like that, more or less similar. Now let's try to plot the rest of the functions and see if it also meets there. By the way, here the predictions are on the x-axis, just like this. You'll have upward, just like that, and narrower than what is normal. Again, let us plot all the rest of the functions. So let's start with number 2. Here, f of x. So it should be color blue. Okay. F of x. By the way, before we go to that, I also mentioned earlier that, or in the other video, that f of x is just y. So if we are going to use y is equal to 3x squared, as you can see, the blue and the red graph overlaps since f of y is just the same as x. So again, this is the normal. The blue is the normal since the a is 1, or a is 1, just like that. Our first graph, the red, is narrower as predicted here. So it's really narrower than that. Again, if I'm going to place a 3, they're just the same, they overlap. So let's try to graph now the second function. And let's see if it really is narrow and is it opening out downward rather, and is if whether the vertex is on the x-axis. So you have f of x is equal to -2x squared. The graph is this, similar or almost similar to this. So it's downward on the x-axis. The vertex is on the x-axis, and it's narrow just like the first. Graph number 3, let's use this. We expect for it to be wider. It opens upward, and the vertex is above the x-axis. Let's try. F of x is equal to 1/2. By the way, the color of the graph is green. X squared plus 5. The green graph is actually here, this one. The vertex is at 0, 5. Same here, vertex at 0, 5. And it's opening upward, yes. The vertex is above the x-axis, yes. And is it wide? Yes, because if we are going to remove this number, this is the normal, and if it's 1. But if we're going to have 1/2, it's a little bit wider. So this is our graph, and it meets the prediction and our graph here. And finally, for our last function, f of x is equal to -x squared. It's the purple graph minus 3. Our predictions, downward, normal, and below the x-axis, it's like this. So it should be below. The purple is somewhere here, right? So below, at vertex at 0, -3, just like this here. 0, -3. Downward, it's and is it normal? Because if we are going to check, it's just simply 1 here, or -1, and the absolute value is 1. So it's like that. This is the graph of the 4 functions combined into one. The first function is 3x squared. Second, which is red. The second function is -2x squared, which is blue. The third function is 1/2 x squared plus 5, which is green. And the fourth function is -x squared minus 3, which is the purple. This is what we have made earlier using our predictions and our solutions, and this is using Desmos. Now, Desmos can be used to verify your answers, as this is online, and our assessments later on are face-to-face. This is to verify whether your predictions are correct or even your answers are correct. So this ends this practice exercise, starting with the predictions on the shape, concavity of the parabola, including the location of the vertex, and then the graph, which started with the vertex and all necessary points.